Hello everyone, welcome to my class. In today's class I am going to cover geometric sequence. So let me start the class right away. First, quick recall about a sequence. A sequence is an ordered list of numbers. Sequences follow a pattern and first few terms suggest that pattern. There are two sequences with the standard pattern that we cover in this class. First, arithmetic sequence, which we already covered in our last class, and now we'll cover the geometric sequence in this class. So now let me begin the geometric sequence. First, the definitions. A geometric sequence is a sequence that has the property that the ratio of any two consecutive terms in the sequence is a constant. The constant is called the common ratio and is denoted by letter R. If A1 is the first term, then the general form of the geometric sequence is given by this form. The sequence of A1 is the first term, and the second term is A1 times R. Third term is the previous terms A1R times R, which is A1R square, and so on. That is, each term is obtained from the previous term by multiplying it by a common ratio. So general formula, an equals to the first term times common ratios to the power n minus 1. Quick example, the sequence with terms 4, 8, 16, 32, 64, is an example of geometric sequence where first term is 4 and the common ratio is 2. Next, recursive formula for the geometric sequence is given by an equals to r times an minus 1. Let's do first example. Write the first four terms of the geometric sequence with first term is 2 and common ratio is 4. So let's begin the solutions. So here, given first term is 2, so the second term is first term times the common ratio. Also the common ratio is given to us, which is 4. So then A2 turns out to be A1 times R equals to A1 is 2, R is 4, so 2 times 4 is 8. Similarly, the third term is A3 equals to second term times the common ratio. We found second term is 8, common ratio is given to us 4, so 8 times 4 is 32. Similarly, the fourth term is A4 equals to third term times the common ratio. We found third term is 32, 32 times the common ratio is 4, so 32 times 4 is 128. Hence, first four terms of the given geometric sequence with this formula are 2, 8, 32, 128. I hope this solution makes sense to you all. Next, let's talk about partial sums of geometric sequence. The nth partial sum of geometric sequence is given by this formula. Sn equals to this ratio. First terms times 1 minus r to the power n all over 1 minus r, where r is common ratio. Let's do example 2. Find the sum of this geometric series. S10 equals to summations 1 over 2 to the n and runs from 1 to 7. So let's begin the solutions. So here first term is 1/2, common ratio is 1/2, and the total numbers n equals to 7. So here, to find the first terms, put n equals to 1, so then 1 over 2 to the power 1 is 1 over 2, so this 1 over 2. And for the common ratio, so first term is 1/2, second term is put n equals to 2, 1 over 2 square, which is 4, so 1 over 4. So second term is 1 over 4, first term is 1 over 2. So to find the common ratio, divide the second term by the first term, so 1 over 4 divided by 1 over half is just 1/2. I hope this makes sense to you all. Hence, to find the S7, use the formula. This ratio, first terms times 1 minus common ratio power n, 7 here, n equals 7, over 1 minus r. So let me show you. I use this formula here. Sn equals to first term times 1 minus r to the power n all over 1 minus r. So for our case, n is 7, r is 1 half, a1 is 1 half, which you did here. So here, S7 equals to then 1 half times 1 minus 1 half power 7 all over 1 minus 1 half. Now simplify the next step. So here 1 half as it is, 1 minus 1 over 2 to the power 7 is 1 over 2 to the power 7 all over 1 minus 1 half is 1 half. The next step, we can cancel this 1 half, and we take the LCD in subtracting these two fractions here. So then we multiply 1 by 2 to the power 7 and minus 1 all over 2 to the power 7, which is here. I hope this simplifying fraction makes sense to you all. So using calculator, this fraction turns out to be 127 over 128. Great. So we found S7 equals to this number, 127 over 128. Awesome. Next, let's talk about the sum of an infinite geometric series. So let me recall. Infinite geometric sequence is of this form: a1, a1 times r, a1 times r squared, a1 times r cubed, dot dot dot. And the infinite geometric series is the sum of terms of the geometric sequence. So let's add all of these terms here. So a1 plus a1r plus a1r square plus a1r cube plus dot dot dot. And with this algebra here, it turns out that the infinite geometric series S infinite equals to a1 over 1 minus r. So let me talk about the summary here. The geometric series or series of form, this is the infinite geometric series. This turns out to be the first term over 1 minus r. I'm talking the sum of these infinite terms. First term over 1 minus common ratio, for common ratio is absolute value less than 1, and if the absolute value of common ratio is greater than 1, then the geometric series, this geometric series, has no finite sum. Great. So now let's do example 3. The series of 1 over 2 to the n, summation start from 1 to infinite, is a geometric series with first term 1 half, common ratio is 1 half. So this infinite sum turned out to be by this formula: first term over 1 minus the common ratio, first term is 1 half over 1 minus the common ratio is 1 half. So simplifying this fraction gives us 1. Awesome. So I hope this computation makes sense to you all. So now we can also visualize this sum in geometrically here. So let me scroll this way. Yeah, we have unit square here, and this sum 1 over 2 to the n and runs from 1 to infinite in the expanded form. This is in this form: 1 half plus 1/4 plus 1/8 plus 1/16 plus 1/32 plus dot dot dot. Then this sum turns out to be 1 by this formula here. And in this geometrical figure, so we have 1 half, add 1 half of 1 half is 1/4, and add 1 half of 1/4 is 1/8, and so on. Then the total sum turns out to be 1, because this bigger square is unit square. I hope this computation makes sense to you all. Now let's move on. Let's do example 4. Determine whether the infinite geometric series has a finite sum. So here, 0.9 plus 0.09 plus 0.009 plus 0.0009 plus dot dot dot. So let's use our geometric infinite series formula here. Solutions. So here, first term is 0.9, and then common ratio is 0.09 divided by 0.9, which turns out to be 1/10. Since the absolute value of common ratio is less than 1, so we can find the sum of infinite geometric series. So by formula, S infinite equals to first term over 1 minus common ratio. Let me show you. I use this formula here. Let me scroll down. Then next step, first term is 0.9, common ratio is 110, so put it here. Then simplify. It turns out that this sum equals to 1. Awesome. Now let's move on. Let me rephrase these questions differently. So in example 5, show that the infinite decimal 0.9999999 is equal to 1. Let's prove this statement. So 0.999999 equals to 9 over 10 plus 9 over 100 plus 9 over 1000 plus . Now this is a geometric series, so we can apply our formula. So this sum turns out to be the first term over 1 minus the common ratio. Here first term is 9 over 10, the common ratio is 1/10. Here common ratio is 1 over 10. So we obtain 1 over 10 by dividing 9 over 10 square by 9 over 10. And simplifying these fractions turns out to be 1. So the questions 4 and 5 is the same questions, only we phrase differently. Awesome. Let's move on. Let's do example 6. Find the number of terms in geometric sequence where first term is 9, the nth term is 729, and the common ratio is 3. So let's begin the solutions. So here, given to us first term, nth term, common ratio, we need to find out the value of n. So by formula, an equals to first term times the common ratios raised to the power n minus 1. So next step, an is 729 equals to first term is 9 times the common ratio is 3 raised to the power n minus 1. We don't know the n, so let's keep as it is. The next step, let's divide both sides by 9. So 729 divided by 9 is 81 equals to 3 to the power 9 minus 1 as it is, and this 9 cancels when you divide both sides by 9. In the next step, let's solve this exponential equations. So to solve these exponential equations, we want to make the same base both sides if possible. So here on our right hand side, the base of this exponential function is 3. So let's rewrite 81 equals to 3 raised to the power 4. So then we have 3 raised to the power 4 equals to 3 raised to the power n minus 1. Then since we have the exponential functions with the same base both sides, then we can only equate the exponent. So we have 4 equals to n minus 1. So hence n equals to add 1 both sides, which gives n equals to 5. So we found the number of terms n equals to 5. I hope this computation makes sense to you all. Now let's move on. Let's do example 7, population's growth. At the beginning of the year 2000, the population of USA was approximately 277 million. If the population is growing at a rate of 2.3% per year, what will the populations be in 2025, that is after 25 years? So let's begin the solutions. Let me do this way. So here, the first term is 277, and then the common ratio is 0.023. So we are dividing these numbers by 100, and n is 25, and we need to find out what is A25. Here we use the alternative growth rate formula, which is an equals to first term times 1 plus r raised to the power n. This is the alternate formula to compute the growth rate. So the idea is multiply the first term by 1 is the starting value, so I'm talking here in this formula, and multiplying 277 by common ratio R produces the amount of growth, and hence adding these two results is the new total value. So I'm talking this formula here, I'm explaining this formula here. So by this formula, an equals to a1 times 1 plus r raised to the power n. In the next step, n is 25, so we need to find out 825. So 825 equals to a1 is first term is 277 times 1 plus r is common ratio 0.023 and n is 25. I hope this setup makes sense to you all. So now next step, so 277 as it is, so we're adding these two numbers and raised to the power 25, and using calculator it turns out that 825 equals to approximately 489 million. So in 2025 the population of USA is approximately 489 million with this rate. I hope this computation makes sense to you all. We finish these sections. Thank you.